All right, so we are looking at the total surface area of a cylinder. So here is our cylinder. Yeah, it's got a radius of whatever r is, and it's got a height, h. And, if you were to unwrap that, you would end up with a net that might look like this. So you'd have two circles. Each of those have an area of pi r squared, because that's the area of a circle. I'll put a link below if you want to explore that idea a little bit more. But the tricky part is this sort of rectangle that you get. I've tried to highlight it here in pink. The length around this circle, if you sort of unwrap it, would become this length of the rectangle. And I think that's the hard part. But if you can sort of wrap your head around that concept, you would know that this length would be the circumference of the circle, which is 2 pi r. And then so you end up with this rectangle in the middle, which is 2 pi r multiplied by h. So then essentially we have three areas we need to add together. We need to add the two circles and then the area of this rectangle. And the way we would do that is like this. This is what the formula is, but hopefully you can see now where it comes from. And our cylinder is going to give us a little twirl. There we go, look at that. And so hopefully it makes a bit of sense though, because it's 2 pi r squared, because you've got two circles, 2 pi r squared plus 2 pi r h. Well, 2 pi r is this length, and h is this length. And the area of a rectangle is just length times width, right? So it's 2 pi r multiplied by h. So that you get TSA, or total surface area of a cylinder, is 2 pi r squared plus 2 pi r h. And then once you get given, some numbers, you can substitute those numbers in and you can find the total surface area of the cylinder in units squared. All right, there is a bit more to this video though, because some of the questions you end up getting asked are about partial cylinders. So I wanted to look at that, and I had a student who came up with a potential formula. It was a bit hard to verify it at the time, but hopefully they came up with what I am going to come up with here. So a partial cylinder is basically, we've got the part of the cylinder has been taken out, sort of a wedge has been taken out of our cylinder. So you can sort of see here that we've got a little section taken out. And therefore the net looks a little bit different, doesn't it? You can sort of see here, it'll spin around in a moment, but we've sort of got two rectangular faces, and then you've sort of got a curved surface, and then at the top you've got two sectors. And then so essentially once you see the net, hopefully you can start to piece together the surface area. But I'll put the formula here because I'm not trying to catch you out. There you go, let's give it a little spin so you can sort of see the surface area of the partial cylinder that we're trying to calculate. Anyway, let's just try and understand this first part. All right, theta. I need to explain this. Theta is the interior angle of the sector of the circle that you've got. So the angle inside here would be theta. And theta is out of 360 because a full circle has 360 degrees. So if we take theta, whatever that angle is over 360, it basically says what fraction of the circle do we have? And we multiply by pi r squared. So that tells you the area of a single sector. Okay, and then you multiply by 2 because you've got two of them. You've got the top and the bottom. Top part here, and then obviously the base underneath here. Okay, let's try and make sense of this next part. We've also got this part here. So it's theta on 360 multiplied by 2 pi r h. Okay, let's think about this length here. This length here is no longer the full circumference of a circle. It's whatever percentage of the circle we have, or it's whatever fraction of 360 degrees we have. So it's theta on 360 multiplied by 2 pi r. Remember, 2 pi r is the circumference of a full circle. So theta on 360 multiplied by 2 pi r sort of gives us this length of this part around the sector. This curved part becomes this length here. Okay, and then you multiply by h, because that we take this length and we multiply by this length, which is the height, gives us this area of this internal sort of rectangle we have here. Okay, and then we're left with r. So remember, r is going to be these lengths here, this length. So in the net, that corresponds to that length there, and then this length is h. So this rectangle has an area of RH, or r multiplied by h, and there's two of them. You've got this one and you've got this one. So interesting there. Hopefully you can sort of see intuitively where the surface area of a partial cylinder comes from. And good luck with everything you're doing. Get in touch if you've got any questions.